And the second topic will be about the principal stresses and strains. This one also you know about in our second year. In first year, you learn about the stresses and strains. In second year, you learn about the principal stresses and principal strains, the main basic terms and then definitions, derivations, that all you learn in the second year, principal stresses and strains. That is a state of simple shear, relationship between elastic constant, compound stresses, and then principal planes, principal stresses, Mohr circle. The next angle of obliquity, that is nothing but the resultant. Wherever we are taking the straight line, that inclined line is called as the angle of obliquity. Then next, some resultant stresses that will be observed here. Then principal stresses in beams. In next same second year, second sem, we learn about the torsion. This one will be we learn torsion, circular, solid, hollow sections, shafts for shear stresses, and then angle of twist, that will be the torsion. And then we'll see some keys and couplings, combined bending and torsion. These are all the theory that we learn in our BTech level. Okay, here for GATE exam, we only need the basic terms that what you had to learn here. First of all, you have to know what are the stresses that have to be occurred here. Stresses are occur isolated or in combination. Is structure strong enough to withstand loads of it? Yes, if sometimes we will tell is because the structure will be a steel material that has to be strong enough to withstand the loads, whatever the loads that we are applied on it. Is it stiff enough to avoid excessive deformation and deflection? No, it is not a stiff, but it can hold the deformation, but there will be at certain point it will release the deformations and then deflections. The next you have to know about the engineering mechanics that will be deals with the statics and dynamics. Basically you have to know about the strength and stiffness of the structure is a function of the size and shape that will be in certain physical properties of the material that has to be learned here. What are the properties that has to be obtained or observed in our day-to-day life in our surroundings? The main basic properties that has to be checked is, first one is the elasticity. Up to what limit it will be the change, it will not change, that will be the elasticity. Next one is the plasticity. At certain limit, the body will be near elasticity limit. After that limit, it will be called as the plasticity limit. The next, ductility. Ductility means it won't give any intimation, it will break suddenly, that is the ductility. Malleability depends upon the material. And then brittleness, it will give us the sudden movement and then sudden breaking of points. Toughness and hardness also, the resistance against its body. What are the indentation present on the material, depends upon the material and the mark, the hardness will be observed here. This toughness and hardness we will see in the strength of material slab. Okay, now we'll see there will be some different forces will be there for any body. One is internal force, another one will be the external force. Here you can observe the internal force. Whenever we are taking a body, here we are taking one body of MN size, total one body is taken here. Whenever we cut the body, there will be some stress will be there. That stress is whatever the load that we apply and then what is the cross-sectional area. Okay, stress is equals to whatever the load that we have to apply divided by the cross-sectional area. Stress equals to sigma equals to P by A. Stress is denoted as sigma. Here you can observe whatever the load that we are applying is P load and then we are cutting at certain position, that there you can observe the stress. That is the axial compression force that has to be observed here. This one is axial tension. This one is pulling of the bar. Pulling of the bar will give us the tensioning of the force. The next we will observe the stretches the body bar and tends to pull it apart from the bar. That is the pulling of the bar we can observe here. There will be some rupture will be formed here. If you observe the pushing of the forces that has to be observed, there will be crushing and then buckling. Compression, whenever there is small column is there, in that column we are applying the forces, there will be a buckling of the forces you can observe in that body. Okay, the next stress, how will define and how will be explained means the resistance offered by the material per unit cross-sectional area. Resistance offered by the material per unit cross-sectional area is called stress. Okay. Stress is denoted as sigma, and then this sigma will be equal to the load by area, that is P by A or force by A. Okay. Then next, what are the units of stress that will be observed is Pascal, or we can call as a 1 Newton per meter square or Newton per mm square, kilonewton per meter square, like that we can write. 1 megapascal is equal to 1 Newton per mm square. This can be these units, and then the stress definition they will ask for your competitive exam. This will be referred by the material per unit cross-section area. Next we focus on the, it is defined as the deformation per unit load or per unit length. That is nothing but the strain. Strain is nothing but the change in length by original length. Whatever the load that has to be applied on any body, it is defined as a deformation per unit length or change in length by original length. It is the ratio of the change in length to original length. Whenever you can observe here, there will be one rod is there. For that rod, the total length is L. If you are pulling or pushing of the rod, there will be length will be changes. That length, change in length or original length that has to be observed here. That the change in length will be increase or decrease of the length. That is, if we are pushing, that is, if you are pushing, then the total compression force. If you are here, you can observe this one will be a fixed one, and then we are pushing means what will happen? The length will be decreased. That is, decrease in length by original length. If you are pulling the rod or pulling that object, then it will give us it will show us the full increasing of the length. That increasing of length will give us increasing of length divided by the original length. That is the tensile strain. Okay, tensile strain and this compression strain you can observe here. Strain. What is the definition of the strain? Is nothing but change in length by original length. Length itself, the units of length is meter or mm or centimeter. Divided by again length means there is no unit. Strain is a dimensionless quantity. In your competitive exams, they will ask what are the units of stress and then what are the units of strain. Units of stress is nothing but change in length. Units of stress is Newton per mm square or megapascals that will be observed. Unit of strain will be dimensionless quantity. Here they give some different for example. Here you can observe a short hollow cast iron they give with a thickness and then with compressive load, and then you have to calculate the external diameter. You have to compute and require the outside diameter D. So the working stress in the compression will be 80. Sigma is given, that is stress is given, sigma equals to 80 Newton per mm square. Load is given, P is 100 kilonewton, that will be changes into Newton, 100 into 10 cube Newton. Area of this hollow sphere will be pi d square by 4. This d square is again they changes into capital D is external diameter. Internal diameter we have to find means the thickness is given. Thickness is given as 10 mm. That's why we are minusing here d minus 20 whole square. Capital D square minus small d square. That small d is nothing but the capital D minus 20. Okay. Then we have to solve this one, and then we have to get the one formula here with in terms of D. And then we have to substitute, we know the value of stress, and then we know the value of T, we know the value of A. A is the formula. Then we can easily find the diameter of D. That D will be 49.8 mm. This is a simple problem. Easily we can easily able to understand, and then we can solve correctly. Next one is also same. We have to find the length of the beam. A steel wire hangs vertically under its height. What is the greatest length it can have? Is the allowable tensile stress sigma T 200 megapascals, density of the steel. Density of the steel gamma equals to 80 kilonewton per mm square. Okay. Now you can observe here density given and then weight of the steel. That is stress is given. Sigma T equals 200 megapascals. Gamma is 80 kilonewton per meter square. Then we have to find the weight of the wire. Weight of the wire equals to pi d square by 4 into L into gamma. This gamma is already given. What is the unknown value is? Only D is the unknown. Length D also, we don't know the D value. we don't know the value of L also. Then directly you can solve the problem. Then you can find easily the total length of the given diagram will be here. P is known, D is unknown. That is the D will be, you can keep same. You can find the sigma T equals to P by A first. Then you can find the D value here. Once we find the D, again you have to substitute in the formula. Then you can find the length of the wire. Length of the wire is here. We'll get the answer is 2,500 meters. Okay, this is the about the stress and strain formulas with the examples. Now we'll see what is the stress strain curve for mild steel, that is for the ductile material, that is nothing but the for our mild steel bar that we are taking. We are taking the mild steel bar and then we are keeping on going on increasing the load. What will happen? It will be changes its graph. Here you can see on the left side there is a stress, on the horizontal it is a strain. If we are increasing the load, the stress strain curve diagram you can observe here. This whatever the stress and strain will be up to certain limit, it is elastic limit. Then it will change some yield point, yield stress point. This yield stress point, after yield stress point, it will changes to the plastic state of the material. Then there will be a breaking point will be observed. In the plastic state of material also you can observe the maximum value, that will be the ultimate stress point we can observe here at the top. The stress strain diagram, based on the stress strain diagram also they will ask some questions. The next, what is meant by Young's modulus or modulus of elasticity? When stress is directly proportional to strain, there will be some constant. That constant will be called as a modulus of elasticity. Stress required to produce a strain of unity. The stress under which the bar would be stretched twice its original length. Then the material remains elastic throughout. Such successive strain represents the stress strain line. You can observe here, this will be O, this will be a strain. Here you can observe the stress. The resultant will be A. The value of E is same in tension and compression. What is E? E is nothing but the Young's modulus or modulus of elasticity. That will be same for both compression and tension. Then that E is directly proportional to the stress by strain. Okay, based on the Hooke's law, up to the elastic limit, stress is proportional to strain. Stress is denoted as sigma, strain is denoted as epsilon. Stress is directly proportional to strain whenever up to certain limit. What is that certain limit? When sigma is equals to capital E. This capital E is the modulus of elasticity or Young's modulus. That must be multiplied by the E. This will be a constant. That E equals to Young's modulus. Then next stress is load by area and strain is change in length by original length. P by A equals to E into delta by L. If you want the change in length, delta equals to PL by AE. This is the formula to find the change in length or change in diameter of that rod. That delta equals to PL by AE. For that we can calculate some examples. There will be some bars will be there with different lengths and diameters. Then we have to calculate the tensile loads here. Okay, these are all the different types of the problems that has to be calculated in our formulas. These are all the problems that already we discussed in our classrooms. Next, Poisson's ratio. Poisson's ratio is nothing but the lateral strain by longitudinal strain. Lateral strain is nothing but the, this one you can observe here, lateral strain is D. D is our lateral strain, longitudinal strain is L. Lateral strain by longitudinal strain is the Poisson's ratio. These are the different types of examples and then formulas that has to be learned here. Strength of materials class. Next we'll go for the structural analysis. Here, whenever we are going to the structural analysis, we have to know about the structure. If a structure is an elastic body, that will be subjected to a system of forces with deformation. There will be some deformation will take place, and the resistance offered by the body against the deformation, then the elastic limit is known as a structure. Structure is nothing but an elastic body that will be subjected to a system of forces. There will be some system of forces will be applied on this elastic body, and then deformation will take place, and the resistance offered by the body against the deformation, then the elastic limit is known as a structure. Up to certain limit, the total structure has to able to withstand all the forces. That able is nothing but a structure. It is also defined as a number of elements that is connected together to sustain a load. If no resistance offered by a body against deformation is called mechanism. What is meant by mechanism? Some number of elements, whatever the elements that has to be observed in our structure or element that has to sustain a load, that has to be withstand the load without any resistance offered by the against the body. If there will be one load is applied on the body, some deformation will be there. Whatever that deformation will be there, that deformation will be has to be opposed the deformation. That mechanism is called as the mechanism of the structure. That means if you want able to demolish a structure, what will do? You had to take some cranes and then you had to blast the building. Similarly, whenever you had to remove some beam or column of the structure, there will be by the external force. Internally, when it will be able to demolish means there will be any rest type of reinforcement will be there. There will be damage of the structure. Then automatically some breakings will be observed. That type is called as a mechanism. Okay, this is nothing but the structure. Now we will go about the structural analysis. Why you have to know about the structural analysis? Up to now, we know in engineering mechanics some types of forces are there, some centroids is there, and then in strength of materials we learned about the stresses, strains, elastic modulus, and modulus of elasticity, Hooke's law, Poisson's ratio. That all we learned in the strength of materials. But here in structural analysis, we had to analyze the structure and then we had to check the structure. It is a safe or how many years it will be withstand. Okay, in structural analysis, the mathematical algorithm process by which the response of the structure to specified loads and actions that has to be determined. This response is measured by determining the internal forces or stresses. That is the stress results and displacements or deformations throughout the structure. Whenever a structure is there with some supports and then with some loads that has to be observed, based on that structure, how it will be respond. That has to be determined here with the internal forces. So there will be, for each and every body, there will be some internal forces will be there. Here also you have to check that all the particles. Okay. Next, structural analysis is based on engineering mechanics. For any subject about the structure, we have to main motive and then main basics is the engineering mechanics. Okay. First, you have to learn about the engineering mechanics and then the mechanics of solids, that is the strength of materials, and then you have to do some practicals, that is the laboratory research work, some model and prototype testing for our model, and then experience and engineering judgment has to be take care of the any other person, and then the basic methods of the structural analysis are flexibility and stiffness method. Flexibility method is nothing but the force method that has to be observed here. That is nothing but compatibility method for more number of structures. That is 10 floors or 20 floors, 180 floors, like Burj Khalifa, 250 floors like that. You have to check this flexibility method. Similarly, stiffness method is used for the displacement equilibrium method. This will be you can observe by using the slope deflection equation. So this is the one of the method that has to be observed. Now we can check the what are the idealizations and assumptions that has to be followed. The following idealizations and assumptions are made during the analysis under normal conditions. Materials are assumed to be elastic. What are the materials that has to be taken? The assumptions will be elastic, and then the materials will be assumed as a homogeneous and isotropic. Homogeneous material refers to the identical particles that exist throughout the material. That the isotropic refers the identical properties in all the directions in the particles of the material. That is the same type of material that has to be used for the structure. The next, the relationship between the stress strain will be linear. That has to be take one of the assumptions. A body is assumed to be a solid, continuous. Then the method of superposition is valid for smaller displacements. The principle of superposition may be started as a deflection to be given point in a structure that will be produced by several loads that will be acting simultaneously on the structure that can be found by superpositioning deflection at the same point produced by the loads that is acting individually for the structural analysis. And then we can use one of the main principle is Saint Vinay's principle is valid for the total structural members. Okay, these are all the different types of the idealizations and then assumptions that has to be learned. One is materials are assumed to be elastic, another one is material should be homogeneous, and the third one will be stress-strain relationship in linear, and the fourth one will be we had to assume the total body is a solid continuous, and the fifth one will be method of superposition that is valid for smaller displacement, that has to be number of points that has to be considered here. Next, we had to go for the classification of structures. How the structures are classified? Classification of structures is based on the physical representation of a structure that has to be checked here. One is the skeleton or framed structure. Second one is the surface structure, and the third one is the solid structure. Okay, what is meant by skeleton structure? Skeleton structure is one which is represented the lines possessing certain rigidity properties. For example, portable frames, trusses, these are all the skeleton structures. Okay. Surface structures is nothing but the surface structures is one which are represented by the surface possessing certain rigidity properties. Example, shells, slabs, walls, these are all the surface structures. Next one will go for the solid structures. The solid structures is one which are neither be represented by the lines nor by the surfaces. Example, earth dams, massive foundations, etc. Okay, these are the different types of the solid structures that we will be learned in our day-to-day life. Okay, now we'll see one by one about the skeleton structures, skeleton or frame structures. There are four methods or four classifications are there. First one is a pin jointed frame. Second one is the pin jointed space frames. This we can learn in the Stat Pro. Pin jointed plane frames, the next pin jointed space frames, rigid jointed plane frames, and then rigid jointed space frames. These are all the different types of the joints and then skeleton structures that has to be learned, and then we'll draw these all the structures by using the AutoCAD and Stat Pro. Then we'll see the plane frames, that is only 2D plane. If you go for the space frames, that is a 3D space frames, there you can see the X and Y and Z directions. For pin jointed trusses, rigid jointed is the constant, which will be in a constant mode that will be observed here. Okay, now we'll see one by one. What is a pin jointed plane frames? Here you can observe the members are connected by means of the pin joint, and all the members that have lie in one plane, okay, in the same plane. These members carry axial forces only. Actually, all the forces, although the pin jointed space frames and then plane frames will carry only axial forces, but here the members that will be joined will be at the same plane is known as pin jointed plane frames. Next we will see pin jointed space frames. Space means it has both X, Y and Z directions. Here for this type of condition, members are connected by means of pin jointed, and then all the members do not lie in same plane. These carry also same axial forces only. This type of the forces will be observed here in pin jointed space frames. For your competitive exams, they will ask you what are the different types of the frames that has to be checked in your Stat Pro. That one will be space one, another will be plane one. Next one will go for the rigid jointed plane frames. Here in rigid jointed plane frames, members are connected by means of rigid joints so that angles between the members meeting at a joint remain same, and all the members lay in a same plane. These members carry axial forces, shear forces and bending moments. This rigid joint is nothing but the constant members that has to be observed here. That constant members will be, we can check here with different direction. The different directions of joints will be, we can find the different conditions that all will be at same point. Members are connected by means of the rigid joint, and the angles between the members meeting at a joint will remain the same even after they lay in the same plane. Okay, this type of the forces is nothing but we will observe. Suppose if you are taking one condition, in that condition we can calculate the axial forces, shear forces, and bending moment of the total diagram. Next, if you consider space frames, in this space frames, what will happen? The angles between the members meeting at a joint remain same, and all the members do not lay in same plane. Here they won't lie in the one plane. In plane frames, they all will lie in the one plane. And then these members carry axial forces, shear forces, bending moment, and then here one more force is there. That force is nothing but the twisting force. Twisting force will be act in the space frames. In plane frames, there is no twisting force that has to be observed. Why? Means there is only x and y direction. There you can find the axial force, shear force, and bending moment. Okay, this question they will ask for your exam. Okay, next one, the second classification is that you can see whether this structure is a statically determined structure or the structure is a statically indeterminate structure. This is one of the main important topics that will be known in your strength of materials and structural analysis. Okay, now we'll see what is my best statically determined structure. Actually, we have the equilibrium conditions that we learn in engineering mechanics basics. The horizontal algebraic sum of the all horizontal forces, algebraic sum of the all vertical forces, and the algebraic sum of the moment must be equal to 0. Then it is called as the equilibrium conditions, or these conditions, whenever these conditions will obey any structure. That means those structures which have analyzed by using the basic conditions, then that structure will be called as a determined structure. If you consider one is hinged, another one is roller, that is the hinged has the two reactions and the roller has one reaction. The combination of these two supports, hinged and roller, 2 plus 1, 3 reactions minus 3 equilibrium conditions equal to 0. Then this type of the structure is called as a determined structure. Simply supported beams and cantilever beams, 3 hinged arches, this type of the structures is called as a statically determined structure. Whenever we see the statically indeterminate structures, these are the structures which cannot be analyzed by using the basic equilibrium condition. Along such summation of the vertical forces and the summation of the horizontal forces and the summation of the moment will be equal to 0. Then the number of forces and the reactions exceeding the equilibrium conditions, that is, whatever the equilibrium conditions are 3, our number of unknowns will be more than that 3, then it is called as a statically indeterminate structure. Okay. Next, we can see what are the examples of the statically indeterminate structure. The statically indeterminate structure or examples are the continuous beams, that is more than 2 supports. For that condition also you can see it is a statically indeterminate. Proper cantilever. In last class itself, I told what is the difference between the cantilever and proper cantilever. Cantilever is nothing but one end is fixed, another end is free. For that type of conditions, for that type of beams, we can call as a cantilever beam. For a proper cantilever beam, one end is fixed, another end is free. Wherever the free, there will be one support we'll consider this. Then we'll keep there one support. That type of structures is called as the proper cantilever beam. Okay. This is the example of statically indeterminate structure. When summation of all the algebraic sum of the components of all the forces, including the support reactions in X, is called as the sigma Fx. Sigma Fy is nothing but the algebraic sum of the components of all forces, including support reactions in Y direction. And sigma M is the algebraic sum of the moments of all the forces about the reference point in the section that has to be observed. These are all the different types of the problems that has to be seen in our structural analysis topic. Okay, next we go the next part, the different types of the indeterminacy. Already we know what is meant by indeterminacy, and then again we'll see how the indeterminacy will be divided. Uh, the types of indeterminacy are basically two types that are used basically on the structural system. One is statically indeterminate, another one is kinematic indeterminacy, or that kinematic indeterminacy is also called as degree of freedom. First, we will see what is meant by static indeterminacy. Static indeterminacy refers to the number of additional equations that required over the static equilibrium conditions to analyze the structure in indeterminate structure. That is, the statically indeterminate is generated as ds, that must be equal to dsi. dsi is nothing but the external indeterminacy plus dsc is the external indeterminacy, dsi is the internal indeterminacy. External indeterminacy depends upon the members and then depends upon the supports you can find. That is, for a plane frame or -3, for a space frame or -6. dsi is nothing but the internal indeterminacy. This will be depend upon the members. That is, for jointed plane frame, m minus 2j minus 3. That is, m equals to 2j minus 3. I have to equate the members and joints with the statically degree of statically internal indeterminacy. Okay, ma? Members, what are the members have in your truss? That members must be equals to 2 times the joints minus 3, 2j minus 3. Similarly, for space frame also the same formula, m equals to 2j minus 3 for pin jointed space frames also. And 3c is nothing but the for rigid jointed plane frame and rigid jointed space frame. This will be you can learn in your MTech level. Next, we will see what is meant by or. Or is nothing but the number of reactions, and m is nothing but the number of members, j is the number of joints. This will be, you can see the internal indeterminacy. Suppose if you take a truss, how many members are there? That members is m. How many joints are there? That joints are the or. The next m equals to 2j minus 3. M equals to 2j minus 3, that has to be calculated here. That will be, we will find here in our condition. Okay, where C is nothing but the number of curves where you have to be required and obtained for open configuration. That is for closed book. In that condition, we can say this one. Okay, this is the one type of the condition that has to be obtained here. Next, we will go for the next topic. That will be kinematic indeterminacy. This kinematic indeterminacy is nothing but the, you can observe here the kinematic indeterminacy. It refers the number of independent components of joints with displacement and then with respect to the specified set of axes. If the displacement component of a structure that cannot be a compatibility condition, then it is called as a kinematic indeterminacy. That is nothing but whenever there will be more than the equilibrium conditions, then it is called as the kinematic indeterminacy. The number of unknowns and displacements exceeding the compatibility equations. Compatibility equations and equilibrium conditions are the same. So this is the kinematic indeterminacy. Here you can see the kinematic indeterminacy depends upon the dk. That dk will be equal to nj minus c, where j is the number of joints, n is the number of joint displacements that has to be observed. In this joint displacement, this will be, you can see in the stiffness matrix, and in finite element method, you can observe this type of the conditions. What are the number of joints are there, number of constraint displacements, how many constraint displacements are there, how many reaction components are there for different types of the structure. If you go for the plane frames for pin jointed trusses, there is two translations will be there. Pin jointed space frames, for this pin jointed space frames, you can observe the 3. For rigid jointed plane frames, 3. And in that 3 also you can see 2 translations and 1 rotation. That is one horizontal and one movement that has to be take the 2 translations, and 1 rotation will consider here for the rigid jointed plane frames. Similarly, the rigid jointed space frames also we are considering 6, 3 translations, and then 3 rotations. And then the degree of freedom, what is the degree of freedom for the internal hinge? We are considering as n plus 2, where n is the number of members meeting at the internal hinge that will be provided. That has to be checked here. Okay, now we'll see some diagrams. In this diagram, we can observe that what is the stable condition, what is the unstable condition of the structure. Here we can observe in this stable structure, all the physical bodies that will deform when subjected to load. That is nothing but any body has some deformation. Here you can observe that all the physical bodies will deform when subjected to load. However, the deformation in engineering structures is so small then that there will be effect of the equilibrium state of the structure can be neglected. When a structure offers a significant resistance to its change of shape, it is called as a stable structure. That is, it is in a constant position, that will be a stable position. When we will call as the unstable condition or unstable structure. When a structure does not offer a significant resistance to its change of shape, it is called as the unstable structure. There will be 3 types will be observed in our day-to-day life. There are 3 types, that is instability of the structure, overall instability, local instability, and then external instability. For any structure, you can observe these 3 types of the unstable structure. Here you can see in this diagram, overall instability is nothing but the reactions A and B in one condition. Whatever the load that has to be observed will be at one corner, that is at eccentric load. Local instability is there is more number of supports will be there, but the joints and then here you can see the hinges also will be more. This is a local but instability. These all are the instability conditions. External instability is by the load itself. It will be some inclined position at one corner. Then this will be external instability conditions. Now we'll see some reaction components and then degree of freedom. For a fixed support, the reaction components are 3. Degree of freedom is 0. 3 minus 3 equilibrium conditions equal to 0. For a pinned or hinged one, the reaction components are 2 and the degree of freedom is whatever the 3 number of equilibrium conditions are there, 3 minus 2 equals to 1. If you go for the roller support, here in roller support the reaction components are 1 and then the degree of freedom is total equilibrium conditions are 3, 3 minus 1 equals to 2. Next we go for the free end. Free end means there is no support is there, then no reactions will be there at the free end. For this, the number of reactions is 0 and then the degree of freedom is 3. This will be, we can find easily. So we can go for the analysis of statically determined structures. Okay. Determined truss, not a structure. Trusses will. First, what is meant by a truss? Truss is nothing but consists of number of members jointed together and form a frame, which is placed against any type of the load. That is in a vertical or in an inclined position or any type of the loading that has to be observed. There is 2 types of trusses we will take in our engineering. One is plain truss and then one is a spaced truss. Plain truss are the members of truss lie in one plane and the number of members required for statically determined truss, the formula is n equal to 2j minus 3. Okay, this is a plain truss. All of you please check here, check the formula. Now we'll go for the next one, spaced truss. All the members of truss do not lie in one plane, but the number of members required for statically determined space, the space truss that has to be obtained here, n equals to 3j minus 3. Okay, 3j minus 6 here. This is one of the formula that has to be obtained here. Next one, basic assumptions that has to be considered here. 3j minus 6. J is nothing but the number of joints. Some basic assumptions are had to take the all the individual members at right. That is nothing but whenever it is inclined or straight, horizontal or vertical, that all members, each individual member had to taken as a straight one. Okay. Next one, all the members are connected by the frictionless hinges. The external loads and supports, reactions and joints only had to be considered here. Okay, this is the assumption that has to be taken. Next, analysis of plane truss. There are four methods of analysis of plane truss. One is method of joint. Second one is the method of section. Third one is the tension coefficient method. And the fourth one is the graphical method. These are all the different types of analysis that has to be considered for the plane truss. Okay, now we'll go for the first one, method of joint. Here, in this method is suitable when two unknown forces attack joint only. Then this worked out necessary support reactions first. You have to calculate the support reactions first, and then you have to choose the joint which is having maximum of two unknown forces, and then for that you have to draw the free body diagram. This type of problems already we solved in engineering mechanics for trusses. We are taking one truss and then we had to consider some of the force at horizontal or vertical, and then we had to take one unknown force and then two unknown forces. Or for that, first we had to check, we had to draw the free body diagram, and then we had to resolve all the forces in two mutually perpendicular directions. This will be x and y direction. And then we had to find out the unknown forces at the top of the joint by applying the equilibrium conditions. Whenever we are considering the truss problem, we are taking one force, whether it is horizontal and vertical, and then we had to clearly find that there will be how many number of unknown forces are there, and then we had to apply the equilibrium condition. Repeat the same process, and then by choosing the joint, and then we had to determine the unknown forces until the forces and the members are determined. That has to be calculated by using the member forces, and then we had to calculate. That is the method of joint problem method. Okay, now we see the section, method of section method. In this method, the suitable which the force is limited and the number of members to be found here. It is stable even there is a three unknown forces. How will find? In last condition for section, we will see only the two for joints, we will see only the two unknown forces, and then we will find. Here more than two, we can find easily the method of section. We have to cut the truss of two parts by the section which passes through the member that has to be concentrated, and then we have to choose one or two parts of the truss, and then we have to draw the free body diagram, and then we have to find the unknown forces at this section by applying the equilibrium condition. Then next we have to repeat the same process in the required members, and we will determine. In this section, it should be drawn in such a way that not more than three members in which the forces are able to work it out or cut out. If you take the section modulus or modulus method of section, only 2 or 3 times you have to cut the section and then you have to solve. Next one is the members carry zero force. If the forces are acting at a joint and two of them are along with the same line of action, then the third force will be at the joint, then it is called as a zero force. Okay. If two forces acting at a joint, then for the equilibrium of joint, these two forces should act along the same straight line that must be equal in magnitude and direction. Then that type of the force will be zero. That means if you take horizontal force HA, already HA will be there, then there will be some 5 kilonewton or 10 kilonewton. Then that HA will be equal to 5. If that 5 kilonewton is not there, then the horizontal force is equal to 0. If there is no force is acting, then that horizontal force is equal to 0. That has to be considered. Here the same members can be zero force. Okay. These are all the structural numbers that has to be considered with the analysis. We learn in our structural analysis determinate and indeterminate structure. Okay, these are the methods that has to be considered. Next, we'll see some more methods. The next class, we'll see about the arches and then different types of the structures we'll see in the next classes. Here you can observe some elastic constants and then models of rigidity according to the strength of material. This will be about the strength of materials. Whatever we've seen up to last slide, this will be the structural analysis. In structural analysis also we learned about the basic terms, about the different determinate structure or indeterminate structure, and then for a plane frame or for a space frame, what are the formulas that has to be considered. Only here we are seeing the theory only. While practicing, we had to take some problematic problems and then we had to solve the number of times. Then only we can easily able to find in our exam. Easily able to answer the test problems. And then we had to make some tips also. How to calculate the stress. Stress is nothing but they give some Newton per mm square load. Then we had to calculate for that load. Suppose they had to ask you what is the diameter or what is the area. For that, the formula had to check. Stress is equal to strain. Stress equals to load by area. Load is given and then area is not given. Stress is given. Then easily has to calculate area equals to whatever the force that has to be given divided by the stress. Like that, you have to solve the number of problems and it will be easy about the strength of structural analysis. Now you will see here, for that conditions also, you have to know about some basics of the strength of material. Here you check here, the modulus of rigidity will be denoted as N here, or in our condition will be taken as R. This modulus of transverse elasticity and then or shearing modulus, it can be considered when shear stress, whatever the shear stress, this will be perpendicular or proportional to the shear stress is proportional to the shear strain is called as a shearing modulus. Shear stress is proportional to shear strain. Shear stress is proportional to shear strain is known as the shearing modulus. That shear stress is denoted as tau and shearing strain is denoted as phi. Tau is directly proportional to phi. Okay, then next for constant to proportionality, we are taking one constant. That tau equals to n into phi. This expression relationship between shear stress and shear strain will give us the modulus of rigidity or n. Modulus of rigidity n. That modulus of rigidity n equals to tau by phi. Tau is nothing but shear stress, phi is nothing but the shear strain. Now we see some more formulas here according to the elastic constant. First formula is the Young's modulus. This Young's modulus gives us the relationship between stress and rain. Young's modulus capital E equals to sigma by epsilon, stress by strain. Similarly, you can see the bulk modulus. Bulk modulus K equals to stress by strain in the volumetric strain. V, volumetric strain. Similarly, you can see the modulus of rigidity. Modulus of rigidity is given as shear stress by shear strain. With some examples you have to consider, and then with some form equilibrium conditions, and then for some problems. Here you can see the shear strain, and then with the state of simple and shear of block, and then total changes that has to be considered here. Some different problems, and then the relationship between E and K is nothing but the modulus of elasticity. K is nothing but the bulk modulus for a space frames. Space frames is nothing but it has having the horizontal, vertical and inclined member, sigma x, sigma y and sigma z. Okay, here you can take one cube and then having with a similar length subjected to three mutually perpendicular stresses of intensity sigma. The bulk density or bulk modulus is given as a formula stress by volumetric strain. Okay, this volumetric strain is nothing but the change in volume by virtual volume. Change in volume by virtual volume equals to stress by K. Then the total linear strain for each side that has to be checked here. Each side of the strain E equals to sigma by E minus sigma by ME minus sigma by ME. Here you can consider the change in length. Strain is nothing but change in length by vertical length. That must be equal to sigma by E into 1 minus 2m. Now, the volume is nothing but a length cube, a length into breadth into height. Okay. Here, in this condition, this will be used as 3 times sigma by E into 1 minus 2 by m. This is the one of the formula that has to be considered here. That is, the equating of the formula, stress, strain, bulk modulus, and then modulus of rigidity. Our Young's modulus capital E equals to 3k minus 3k into 1 minus 2 by m. This is the formula that has to be taken for the relationship between Young's modulus and bulk modulus. Now we'll see the Young's modulus and shear stresses. The formula will be E equals to 9k n by n plus 3k. These are all the different formulas that has to be used for our relationship between the Young's modulus, bulk modulus, and the shear. Okay, these are the different formulas that has to be considered, and then you have to solve the different formulas. Okay, ma'am. Today's class is about the shear stresses and then bulk moduluses only. Next class we will see about the arches, and then we'll see about the fixed beams, continuous beams, and then different types of the structures we'll see in the next class, last class. Okay, students. We had to prepare well for the more number of gauge problems by using the different topics, and then you had to solve the different conditions. Thank you, students.